Hi, this is Michele Aslanides, and I have a presentation for you on disruptive technology. I had a lot of fun researching this topic and learned quite a bit. I think there were a few technologies that I was already aware of, but I was able to further my knowledge. So I hope that as you listen to this presentation, I hope there's some interesting things that you can get out of it, and maybe you learn a little bit more about some of these technologies. So before I get started, I want to take you through some disruptive technologies through history. So from the harnessing of fire or written language, roads, and agriculture, these were some pretty disruptive technologies of the day, and enabled society to grow and develop in terms of written language and the way we produced food and the way we moved about the countries that we lived in. The printing press enabled mass production of works of literature, which enabled more education and the spread of ideas. The steam engine really fueled the Industrial Revolution with moving goods across large areas like big countries. Vaccines had been invented and actually helped minimize the spread of disease and enabled people to live longer lives. Electricity, it's so important in our current life, but it enabled a lot of revolutionary things back when it was invented as well. And then microprocessors and the internet. So microprocessors enabled computing power, that we have now in our computers and our cell phones, and the internet made information readily available at our fingertips, at all times. So then, looking at the disruptive technology of today, I wanted to talk about 6 items in particular. There were many more out there, but these I found to be really interesting, and so I wanted to dive into these a little bit in more detail. So the first one I wanted to talk about is Li-Fi. So Li-Fi is a wireless optical networking technology using light-emitting diodes or LEDs for data transmission. Unlike Wi-Fi, it uses light, whereas Wi-Fi uses radio frequency to transmit data. And there really are some cool ways that this could be used. So for instance, between cars, sensors on cars could pick up the light from another car, and that they could be communicating through data transmission about speeds, distance, that sort of thing, to enable automated driving. If people are walking by a storefront window that has Li-Fi enabled light bulbs, they could be transmitting data to their smartphones with advertisements about sales. And then on airplanes, right now Wi-Fi is only enabled above 10,000 feet, and that's because it uses the same radio frequencies that air traffic controllers will use to talk to pilots. So there's a safety risk there. If an airplane used Li-Fi, it could be transmitting data, but on a completely separate network than what the pilots use. So passengers could be connected through Li-Fi during their entire flight. And then lastly, an interesting one, right now ocean exploration through equipment on the ocean floor is done with a cable for data transmission. Using Li-Fi, if the ship were able to transmit light through the ocean, then it could stay connected that way, unless it went deep enough where light wouldn't penetrate, and then Li-Fi wouldn't work. Next is the Internet of Things. The Internet of Things is a system of interrelated computing devices embedded in everyday objects. And really anything with an on and off switch can be connected, and it can be connected to the internet, which allows you to access through the cloud any of these devices that are connected. And we often think of these as household items that we can connect to. I have, for instance, the Nest smart thermostat here, that will learn and will sense whether there are people in the room. And if it senses that the room is empty, it'll automatically turn the heat down in the winter, or maybe the air conditioning in the summer. And then Amazon Alexa, which uses natural language processing and analytics in order to capture human voice and then transmit that into an action to either, let's say, turn on your playlist or set a timer, or in this case, turn on or off a faucet. And then I also found an interesting, an oven actually that can be controlled through your smartphone. So as long as there's an internet connection, right? So this can be enabled and you can use your smartphone to turn on and off your oven. It's not only limited to household items, though. You can, jet engines, for instance, or oil rigs could also be considered as part of the Internet of Things as well. So the next thing I wanted to talk about is cryptocurrency and blockchain processing. So it was developed by an entity named Satoshi Nakamoto, which I say entity because we don't know if it was a person or multiple people. It was done anonymously in 2008, and it democratized currency through shared ledgers. So after writing transactions to the blockchain, it has to be done through very sophisticated verification steps through a peer-to-peer network where computers are linked upon into a network, and they work to verify transactions through solving complex algorithms. And once an piece of information is solved and it's written to the blockchain, it's given an individual hash, or a hash is a series of letters and numbers that are a code for explaining exactly what the data is. And it's very secure because it actually links back to the block before it, and so there's a record of all the transactions that have happened. And to undo it or to manipulate that, you would essentially have to change everything in the entire system rather than just altering one block, because it wouldn't verify and therefore it wouldn't work. It wouldn't accept it. So it's a very secure system. And essentially what it's done in terms of cryptocurrency is it's solved the double spend problem, where because electronic currency doesn't have a physical representation of money, it's all just numbers on a computer, there is a risk of the double spend problem, which means I could have an amount of dollars and somebody else could try to copy or take that same amount of dollars without having a physical transaction. And that's why banks have to be the ACH clearing. They make sure that that is not being duplicated. So blockchain addresses that problem. Next is virtual reality. So virtual reality is a simulated experience that mimics the real world. Users wear a pair of goggles that have images projected within them, so it enables users to see in like a 3D world that mimics the look and feel as they turn their head and as they look around. They're able to see the images as if they were in a real world. And it also uses sound and environment with sensing where your hands are in order to really create this artificial world that feels very realistic. So the way it's being used in a couple different ways actually is, for instance, training within cockpits. So it's being used to create a more realistic environment for pilots as they train with the cockpits for different situations that could happen. And then also with doctors, there's a lot more that can be done. Let's say for a surgeon, for instance, to do some training before they go in and start operating on a patient. So it's that elevated training that can't be done through books or through normal classroom settings. So it's an interesting way of disrupting that training environment and creating a more real world. And it's also been very popular within the video game industry as well. That's kind of where it's gotten its start, and that's where I think most people probably have come across it or have experienced it themselves. But it's being used outside of the video game industry now and disrupting a lot of more traditional technologies. Next is artificial intelligence. So artificial intelligence is a computer system that performs tasks that would normally require a human. So these could be visual perception, speech recognition, and decision making. And it's all meant to mimic human capability. So there's a couple examples here I wanted to highlight with the 3 examples that I've listed here, with natural language processing, machine perception, and motion and manipulation through robotics. The first one, actually there's 2 that come from IBM. The first one being Deep Blue, which was the computer that beat Garry Kasparov in chess in 1997. The second one being Watson, which is also produced by IBM, which is an AI system that goes out and accesses its databases of information, and it was featured on a show on Jeopardy, actually, to compete against 2 humans and won. So both cases, the computer came out victorious, both in chess and in Jeopardy. Then Sophia is a robot that's been developed to recognize facial features and social cues from people, and to also respond similarly. So it's actually an interesting view if you go out and look up Sophia. The interviews with her are very interesting. It does still seem very much like a robot, but you can see the improvement that AI has made to look more human-like and to have more natural human-like conversations. So that's all AI intelligence that's wrapped into that as well. And lastly, for visual perception, this technology is being used in automated cars, so driverless technology, all the sensors and data processing to find obstacles and avoid people, let's say, on the road. All that goes into that technology as well. So next is 3D printers. So 3D printers uses an additive manufacturing process versus the traditional subtractive manufacturing process to make complex geometries for parts or equipment. Some of the interesting areas where it's being used is in the healthcare industry, and then jet engines, and then also I've highlighted an area where they've started 3D printing houses. So they've been able to make houses within a week by additive printing them. But in the healthcare industry, Smile Direct Club uses them to make their invisible liners for orthodontic teeth correction. And then also, too, doctors are able to model very complex geometries for very specifically designed parts for surgeries. So, for instance, on the skull, you see there's if an injury happens and there's a need to have a replacement bone, right? There's a part that can be made very, very specifically for that individual person. And then on jet engines, so parts can be made in very complex geometries that enable designs that weren't achievable in the past as well. So last for the class, I've got some questions. So these were just 6 disruptive technologies, but what other technologies exist today that are disrupting and are just really cool to talk about? Post some disruptive technologies in your comments and explain some of those to the class. My second question, how will these technologies and others affect your life or your job? So we talked about self-driving cars and robots that can do human tasks. So how will that affect your life and your jobs in the future? And then why do companies need to be aware of disruptive technology? What makes it something that business or companies should be mindful of? So thanks everyone for listening. I've got my sources down below. Hope that you got a lot of the presentation. I had fun doing it. Take care.